Okay, so welcome everybody to the Richmond Fredericksburg Computer Society of IEEE's What Every Software Developer Should Know About Cybersecurity webinar and panel. The following webinar is based on the fact that many software developers have received little or no formal training in cybersecurity. Many more people develop software who don't even have the title of software developer or engineer. Specifically for internet connected software, this is becoming very critical to the operation of our world, and there's been several high-profile hacking events that keep revealing the risks of cybersecurity shortcomings. Many of these shortcomings show up repeatedly in software development or in development of software for embedded devices. Our panel of 4 cybersecurity professionals will discuss the problems that they repeatedly see and that they wish every software developer knew about cybersecurity. With that, I'd like to introduce our panel. We have Dr. Milos Manic. Go ahead and introduce yourself, please. Thank you.
Hello, everybody. My name is Milos Manic. I'm a computer science professor at VCU, IEEE Fellow and Commonwealth Cyber Initiative Fellow. I'm a director of VCU Cybersecurity Center at Virginia Commonwealth University. Our Cybersecurity Center is a center of academic excellence in cyber defense and cyber research, and there's only 4 institutions in Virginia that have designation in cyber research. Glad to be here. Back to you, Johnny.
Thank you so much. Next, we have Steve Proskowski. Steve, would you like to introduce yourself, please?
Hey, Johnny. So I'm the security test and evaluation lead within CISSP to test our in-house programs that we use for our internal use.
Thank you, Steve. Mike Geipel, would you like to introduce yourself, please?
Yeah, so I've been a principal software engineer, embedded software engineer for Norton LifeLock, formerly Symantec, and this actually the topic here calls to me. True to the openings, I had a little knowledge of cybersecurity when I first joined Symantec 8 years ago, and much of my background has been in factory and building automation, and where we really hadn't been concerned with attacks. And I did some in telecom work, but that was mainly at the protocol level. So most of what we're going to be covering are the sorts of things that became very important to me working for Symantec and then Norton LifeLock in covering the embedded world, which is it's not someplace where you would normally consider cybersecurity to be a big deal, but it is. So we'll get into that, I'm sure, later.
Thank you, Mike. And my name's Johnny Johnson. I too work for CISSA, the cybersecurity division of Homeland Security. I've been in the government for 23 years. I've been a software developer for a good deal of that time. Recently, in 2006, I got my CISSP certification. So I do have a background in security. And with that, maybe we should jump right into the questions. So let me ask each one of our panelists this question. What are some of the common problems that cybersecurity professionals keep seeing over and over and over again? Can we start out with Dr. Manic, please?
Yeah, well, there's one problem in cybersecurity that we see over and over, and it's called the human. Regardless of training, regardless of courses, regardless of certifications, humans are necessary. Human in the loop, at the same time introduce a wild card of sometimes unpredictable actions. And I would say that training, not only in topical training on phishing or some other training, most important training is in inquisitive thinking, in thinking what can go wrong. is what we are seeing legitimate or not, and similar questions. Back to you.
And Steve, how about you? What do we see all the time?
I would say it's the software that you don't necessarily know that you have as you're developing the code, all of your third-party libraries that you pull in that they're always updated constantly, but saying one of the older versions, not updating with those libraries. I haven't touched my code in 4 years. New code, new vulnerabilities come out every day against the old libraries and the old infrastructure that's sitting on those.
And Mike, I think that also applies to embedded devices as well as application third-party libraries.
So yeah, it does indeed. So these embedded devices, they talk to other services like cloud services that may be misconfigured so that they're open to be accessed in ways that they weren't intended by the developers. The number one issue is actually, you know, bad code is making and when I say that, I don't mean that the code itself is necessarily bad or that the developers who made them are bad, but that they didn't take into consideration the sorts of things that like the unpatched security vulnerabilities that have already been mentioned, or anything that might cause you to not be able to accept in a robust way unexpected inputs or otherwise invalid inputs. The other thing that is not really cybersecurity, but it becomes really, really important in this PII, which is personally identifiable information, privacy, GDPR. These are kind of adjacent to cybersecurity, but they can be used for intelligence gathering by bad actors to find people and try to access them. So there are lots of other things, but we can talk about. There's a whole new slew of attacks that involve machine learning and artificial intelligence. And artificial intelligence, not in the sci-fi realm of things, but you know, just being able to make very quick algorithmic choices as to this didn't fail, so this didn't succeed, so I'm never going to try all the other things that would have worked, would have been dependent on that. And the software that's doing these attacks, they're getting far more adept at decision making behind the scenes. So I'll leave it at that.
I also believe that, am I muted? Okay.
Yep.
I also think that a lot of the intelligence and machine learning are also being picked up by bad actors and hackers. And so not only are we using them in our applications and in real world government applications and industry applications, but the hackers are also taking advantage of these advanced tools as well, I believe. So that makes things even more critical that we take a layered approach to security, correct? So that being said, so Dr. Manic, what do you think every software developer, either professionally trained in school or home learned, should know about cybersecurity? And do you think there's a point that they should, where they should ask for help?
That's a good question, Johnny. So the typical answer is that software developers should know what the software is intended to do, what the software is intended to communicate with, and the first immediate response is, well, you need to know attack surface, you need to know attack vectors. This, however, assumes understanding of what the software is supposed to do, and I think that's a critical point. We tend to chase deadlines and release dates, and we don't design with security in mind. We design with deadlines in mind, and things get lost in that race. What Mike was and you were mentioning, AI, machine learning, things are getting just worse because that tools are available to both sides as any kind of tool, and we are getting into situations where things happen so quickly, and we are essentially watching AI, machine learning actors on both sides talking to each other, responding, and it seems like we are starting to take a more passive role as opposed to actually controlling these AI machine learning entities. Back to you, Johnny.
Okay, thank you so much. Steve, what do you think about that same question?
I think Milos hit on it a lot. It's knowing what your software is intended to do, what's the inputs and outputs, and how is that data supposed to be formatted. Because you can do whatever you want in your application, but it's where the inputs and outputs are where the attack surfaces come from, and knowing how the software is going to be used if you're using an enterprise and using a layered approach of this and microservices, like this service talks to this service, but one service say implicitly trust anything that comes from the other service. How do you know that somebody's not sitting in the middle playing with the data and then manipulating it or just ingesting it completely?
Yeah, that makes a lot of sense to me as well. I think I read an article one time where 60% of the vulnerabilities are either with how an application handles data or with the IO, the actual access to the application itself, enterprise identity and access management type scenarios. So, Mike, same question to you. When what should they learn about cybersecurity, and when should they ask for help?
Well, I would be inclined to take it almost the basics here. Complex code is bad code if it can be done simpler. And I'm inclined to repeat that, but there will be bugs in any system that you write. There will be bugs in code that others on your team will write. It's our shared responsibility on being on a team to make sure that the code does what the authors actually intended. Things like unit test, where you actually test each and every feature that you wrote. This is just unit test. This is not even application test. Just the unit test to make sure that the code actually does what you want it to do. This is something that is not pushed very much in. I didn't learn it in school. It wasn't something that came up much there. But in industry, this is key, and you can tell the difference between good companies and bad companies. The good companies care about this sort of automated test, and the bad companies don't. The design systems that gracefully handle the unexpected and nonsensical input. So if you're seeing something through one of these mechanisms that we've already talked about that doesn't make sense, you shouldn't just try to parse it and go. There should be something that you should be able to identify things that are clearly not intended for the system to handle. And the last, which we haven't talked about, is don't write your own security protocol. Don't write your own authentication. Don't write your own encrypting mechanism. The chances of you getting that right, or for even a very talented team to get that right, approaches zero. So don't do it. There are plenty of people. Yes, it means that you're dependent on an outside library. Just get used to it. You have to make sure that when that library gets updated, you need to update your systems. You need to make sure that your system can be updated without user intervention, because most of the old routers that required firmware updates to be done, they were out to people, and 96% of them never got a firmware update, even when there were features that users wanted. So having an automated system for at least in embedded systems for software to get updated, so that if you're dependent on a library, as sometimes you should, and that library has a fix, you want to get that fix and you want to push it out to your users, and you don't want to have a discussion with them about going to a particular site down follow these 15 steps to put it in. This is the classic light bulb hack, you know, where the update to it took forever to roll out. And it was, you know, because it wasn't designed in the system.
Yeah, I can totally agree with that. The one thing that kind of makes me think about is, you know, if it's an embedded device and a user has to go through a lot of hoops to update it, it probably isn't going to get updated, right? I mean, human beings like to take the shortest path, right? So thank you for that answer. That kind of leads us into another question. This is not really kind of in order, but it kind of leads us to the major hacking events like SolarWinds. What does this tell us about security of our supply chain, and is there anything that needs to change there? So, Dr. Manic, do you think you could talk a little bit about that?
You guys go first, I'll go last. So this one.
Mike or Steve, either one of you?
I'll let you go, Mike.
I can take a whack at it. So the key thing I think that we can learn from SolarWinds is that supply chain attacks can be targeted. There was this. There's been a lot of discussion about supply chain attacks coming from something that happened a few years ago with a supposed hardware supply chain attack, but in software, this particular hack was running rampant, I guess, I don't know, internal systems for months and months and months and months, and it was only discovered because Cozy Bear, the folks who were presumably the ones to launch this attack, got aggressive and started to go after cybersecurity companies who could detect it, namely FireEye in this case. So, the point is that this was an attack that actually affected lots and lots and lots of people, but they only cared about certain institutions that they wanted to actually follow up on. Once they were able to follow up on it, the second thing that we learned from this is that a small vulnerability can lead to others. Here's a case where this particular attack just provided a foothold, and then other tools were used to then traverse the networks into which they got as broad a connection that they did. This has to do with the federal government. They focus a lot on offensive capabilities and not so much on the defensive capabilities. They figure that that everybody who's inside is safe. So if we can prevent people from getting inside, well, they're going to need to kind of break things up, like companies like NortonLifeLock would probably do. Different teams have access to different resources, and not everybody has access to all resources. And the other thing that I think that would be a lesson, at least from a policy perspective, I think the federal government probably doesn't focus enough on commercial industry standards, on ways in which to get the industry to be able to that provide services to the federal government to actually consider their consequences and in the network, and make sure that they have the kinds of protections on their side to prevent these. In this particular case, this was an attack. The root cause of this was actually an attack on the DevOps system at SolarWinds. So it was not a change to any code that was checked in. After it was checked in, and as it was being packaged for delivery to all the other systems, that step, which didn't have all the protections as the others, had a little bit of extra code added to provide the attack, and this was just used as a foothold. So the lessons here are even though they sprayed this, lots and lots of people use the software, only certain institutions were targeted, and the fact that they could target it as well as they could is a lesson in and of itself.
Steve, do you have any comment on that?
I would say it shows that the software supply chain is vulnerable. It's like any network. It's network connected. Historically, it's probably always been the hardware supply chain because that's physical things that be intercepted. And now you have software, your networks, everything lives on it. Including all your developers and everything is becoming interconnected to use third-party libraries and research on how to do different pieces of code. You got to access the internet. Do you have all those systems connected together? Do you have them segregated off, be separate and don't touch each other? Don't fit where your coding is actually touching the internet. A lot of things now to start thinking about. And how do you secure those even more to ensure that what you put in is what you get out?
All right, right. And Dr. Manic?
And so I'd like to follow up on what Mike was saying, that these are the common vulnerabilities are measured in hundreds of thousands in last couple of decades. And what's interesting in this one and why FireEye caught it in the first place was they were looking at behavior analytics, who is logging in at what time from what IP at what. So it just something was out of the regular profile, and that's probably a good thing because it tells us that by profiling behaviors we can tell a lot what's normal, what's abnormal. However, both sides know that, so that's something to keep in mind.
And let's talk a little bit about, so this is kind of controversial. I recently well, not recently, but 2006 graduated from college as a software engineer. And at that time, I didn't have to take too many cybersecurity classes. In fact, I didn't take any. There was a couple of professors, there were a couple of professors that did emphasize certain bugs that might come up in the development process, but they really didn't go into cybersecurity as much. So I want to ask the whole panel this. Do you think cybersecurity training should be mandatory for everyone that's getting any kind of computer training, developers, software engineers, cybersecurity professionals, even architects and electrical engineers? Should everyone be required to take at least Cybersecurity 101? What do you think? Just free form, guys.
Well, probably it's becoming a must. But again, how to articulate this so it's effective. And we all heard stories about phishing, training against phishing, and all of us complete this training and on regular basis. I can tell you a story about someone who got an account of certain government agency, and at one point trusted that government agency, nothing can go wrong when you're there, except it did go wrong. And now what? In national labs, I believe this is a relatively public knowledge, or let's talk about general a company. It turns out that after training, phishing training, after a while, when you do a testing of your employees, it turns out that 50, 60 or more % actually just again click on link that they shouldn't. So what's happening is training not frequent enough, or is it not challenging enough? What's happening? So I think some training and some education is necessary, but how do you formulate it? How do you articulate it so actually it's effective? I think that's a real trick, because we are talking about humans, and I don't know if anyone has figured that out yet.
I suspect some of the problem with figuring it out is the bad guys are also really good at figuring out how to sucker people in. So they're actively trying to fool you, and figuring out how not to be fooled is tough.
So part of the challenge there, and this is why I brought in privacy and PII and that sort of thing, is one of the things that that anybody who makes an is looking for oftentimes is looking for information about people even before they make their first attack. But certainly after they want to find out names of people, their responsibilities, and what they might have access to and how to phish. And then they will craft messages that are directed specifically at them, using the names of their managers or whatever, to get whatever they're trying to get. I know that at LifeLock, we would get periodically, and we were told that this was going to happen. We were sent messages that were supposed to look like spam, and and if we saw one, we were supposed to identify it and report it. And if we clicked on it, then we would be offered an opportunity to take some training. So, and this is something that they would do without any attempt at making people look bad. This was not, so this is not something that was part of the reporting chain or anything. This was just, we need to get everybody to be sensitive to this. And, the first few were kind of obvious, had misspellings and stuff. And then they got more and more involved, and they were really good about it, and it was kind of fun, once a week or so we would get something and would have to, it's like, okay, so is this one? Anyway, but there's a, when we say, so going to the original question about cybersecurity training is not something that you're going to take a class on, like Cybersecurity 101, and then you're going to be done. It's just not going to happen that way. So and the reason why is because there are many layers to these vulnerabilities. So when you take Programming 101, you don't learn about databases right away. So you're not going to be, and it won't, and so you should know something about how to avoid going past the end of an array. If you have a programming language that allows that, you have to be able to know how to make recursion stop so that you don't so that you don't go past the end of a stack, that sort of thing. This is all old hat, I'm sure, for most people. But then when you learn but at that point, having about sanitary might not be terribly relevant to you. Likewise, when you get into when you start doing databases and we talk about various types of injection attacks, that's great. But then you probably haven't yet learned enough about networking to know about some of the protocol issues that you need to be aware of. This is not something that you're just going to have a class or two and you're going to be all trained up. This is something that really needs to be part of the curriculum starting at the beginning. So when you take your first class on software, how do you make sure the software does what you want it to do? How do you make sure that when you have input from users, that you get the input you expect to get? And do you handle it well if that gets if the input that you got was not expected? When you start dealing with protocols, or even multi-thread, before you get there, just dealing with multi-threaded issues, handling the various lock scenarios that can contribute to vulnerabilities. These are all important things, but they're not something that you're just going to, here's a set of guidelines, go forth and write good software. It's not going to be like that.
Yeah, I would have to agree with that. Steve, what do you think?
Yeah, I mean, there's a lot of different pieces. Like touching on the part that Mike brought up with the PII and like personal information. I mean, social engineering, social networking is all new. It's what, a decade old now almost, and it needs to go back even farther than cybersecurity 101, going back in like like the grade schools. Uh, you were taught then, don't go to a stranger's van, don't go home with strangers. Well, now all of this stuff is coming out to ask about, looking like games, asking what's all of this information. And there's police departments out of thing, don't give this information out. You're giving away all of like your secret hints, everything to recover passwords, so somebody else can recover that for you. So we have to go back to that, and that in social engineering. And really, social engineering is what all that is. But then cybersecurity, like Mike said, it's not just once and done. It's like as you start going through the different like cyber courses, I would say either like programming, engineering, architecture, even program management. Like as you progress through it, it should also include the different pieces of cybersecurity, the different ways vulnerabilities could come about, and just education and education. And they're just staying up on what's, I mean, lately it's staying up on what's in the news as to find out what's going on, but doing like searching like CVEs or like OWASP's top 10.
Yeah, and speaking about the OWASP top 10 and the CVEs, so there are many tools out there available to software engineers to analyze the code that they've written and maybe provide some insight into vulnerabilities. Um, Maybe we could talk about that for a little while. Steve, I know you have a couple of favorite tools that we use at work, right?
Yeah, I got some favorites. I don't really like to name names on them, but there's a bunch of free tools out there that cover all the different programming languages. They're mostly language specific, but they're there to help anybody. And well, free, I mean, they do a good job for what you're paying for it, which is nothing. To help you identify issues that might be there. That as you code, you're your own worst enemy as a developer. You look at the code, you think it's good, and then as like a unit tests, not just the positive unit test, but you need to test the negative unit test to see what if I put stuff in that should not be allowed to go in, what does my code do? Does it cause errors? And now I was doing like a stack dump inside a web browser to the user and giving away all the secrets or something like that. And then it's just how everything interconnects with one another. Your front end to your database, what is traversing that part of the network, how are you storing your data, and just little tips and hints as you go through coding. And as you learn, as you see it pop up on the screen, you're going to learn. And I'd be able to take that knowledge and not do it again and progress with that.
So, Dr. Manic, in your professional career, do you see people in the universities recommending certain tool sets over others, or has there been any kind of push in that direction?
Well, so in courses and in research, we use a number of freely available tools, and I'll mention a couple, but I'll try not to go into names like, you know, Wireshark, Snort, and Nmap, and Metasploit, Burp, and so on. But depending on a problem application on software developing, you need to start with, typically we start with some packet sniffers, network security tools, and then if it's web, then we try to focus on web vulnerability scanning tools like Burp and others. So there's a lot of tools available, a lot of tools that we're teaching. I think one of the tricky ones, and we've done some research and published some work on it, is understanding what the tool tells you. So it's not that much of an issue of installing and running the tool. But when the tool produces the output, what does that output mean? And it's not always the most friendliest output that you can imagine. So for wide use, I think this is the segment that will need some more user-friendly improvements. Back to you.
And Mike, what are your thoughts on that?
So in the embedded world, so I'm my my response is to be very Linux centric, just because of the kind of work that I've been doing. So Valgrind is an awesome tool, and if you're doing it on a platform that Valgrind hasn't been ported to, it can very often be ported to that without too much effort. But even so, you can probably, if you have something that can be cross-compiled, you can do a lot of this analysis on a platform that is readily available, like, you know, an x86 kind of thing, where you find resource leaks, you know how much of your stack is being used, you know, and then make use of features the compilers that you already have. So compilers for over a decade have had things like the stack smashing protector, SSP. So this is a feature of compilers that's been around for eons, and people are still compiling their products without having this feature turned on. This is a feature that puts a little marker on the stack so that if your stack gets overflowed, it won't allow it. You know, it actually causes an exception, which you can capture and then do something gracefully with. You know, this is the sort of thing that you can that you can make part of the system that you have. There are various other tools for creating alternate inputs. There are lots of open source fuzzing applications, and I'll let you Google that. You know, but basically, it makes small variations on good data to make bad data, and see how your system responds. It does mean that you're going to be spending a lot of time running these, but it's worth it in many cases. And then, you know, to the point that was already made about unit tests and acceptance tests, yes, you should have them, but if you don't actually check to see whether your coverage numbers are actually decent, then you're probably not doing it right. So just like Milos said, if you have to know what you have to actually generate reports that you're willing to actually dig into and say, I have a resource leak here, I need to stop that, or I don't have coverage in this entire module, I probably should improve my unit test or my acceptance test for that. You know, and there are lots of tools, and I guess and of course there are plenty of tools that you can also use that would be to be on the adversarial side of this. So Metasploit was already mentioned. You know, you could actually fire up Metasploit. It's free and freely available. It's easy to run. You do have a little bit of experience with it to use it against something you're not familiar with, but you're probably familiar with your own software. So you can probably find things that you want to try, or your own product, I should say, because software doesn't exist on its own. It's usually part of something else. In my case, it's embedded. It's an actual physical thing you can hold. But in many cases, the software is part of a package that is a product, and it's one part of the software may not think of it that way, even though it's part of something else. So, you know, use the tool. There are plenty of tools, and you know, Google's my best friend. I can find out lots of things using Google. And if you think you know what you want to try to accomplish, and you can probably find it somewhere on GitHub.
Okay, so Alan, I think we're probably past the 20-minute mark for our question and answer. Are there any audience questions? Should we open it up to the audience to ask questions?
Definitely.
Now's your time, folks.
Hi. So can you guys hear me?
Yes.
Awesome. My name is Devin Gardner. I'm 21 and I go to the University of Virginia. I majored in computer engineering. And mostly my concentration has been in artificial intelligence and machine learning. And I'm not sure that I'm going to be able to get the chance to take a cybersecurity class before I leave my university. What do you guys suggest would be the best course of action for me to take as a software engineer in my from a career standpoint to learn more about cybersecurity and improve my skills?
That's a great question. Panel?
So first, if you're at UVA and you're a senior, right, or there should be plenty of options starting from, I would say network security is one of security 101 courses at all universities. So there's that will be probably first choice if you have interest in doing so, and then there are other courses. So there's definitely options that you can partake in at universities.
Mike or Steve, do you have?
Well, I'm not entirely certain of the context, but I'm going to make the assumption that that the asker of this question would like to follow up on cybersecurity on their own, kind of outside of college, based on what he said. You know, one of the things that might be just a good exercise to do, there are lots of opportunities if you just Google capture the flag. Participate in a few of these exercises. It'll just get you thinking about the ways in which things can go wrong and how to and how you go and how you accomplish it. Some of them have more. I personally don't know we had an internal resource within Norton LifeLock, so I'm not familiar with the publicly available ones, but there are some I know they are, and some of them have more of a tutorial aspect to it, and some of them are just you know, here are the flags and go after them, and they start easy and they get more complicated. If you ever go to any of the conferences that like the B-sides and that sort of thing, where they have the have captured the flag events. They're fun events that you can participate in. It's best to, if you have an opportunity to do that, I would strongly recommend you do it as part of a team, because then you'll be talking with other people about how they're attacking things, and then you can think about it. It's helpful, even if your interest is being on the defensive side of things. It's helpful for you to hear how people think through the problem of doing the attack side of things, just to see what it is you're defending against.
Yeah.
I would add to that, Johnny, that there's other like resources out there on the web. I know OAuth has a ton of stuff out there. That there's different web servers that you can spin up that they have that you download. You put in a container, you can put on a bare metal server. They put a lot of information out about different types of vulnerabilities. They try to be probably as generic as possible, but it's like a cross-site scripting. Multiple different computer languages are affected by that. There's different web servers that are everything's affected by it. So they go very general and to give you a high-level overview as to what it is, why it's bad, how to remediate it, so that way you can learn as you go along. And then some of the intentionally vulnerable websites they have that you can put up and run, it's almost a gamification that you can go through and figure out where things are, try to put in, say, SQL injection or cross-site scripting, and there's numerous different things that you can do with those.
Yeah, and to add to that, I would say that, you know, the government itself offers quite a few resources. MITRE has a lot of information on their public web pages, and I believe even our organization, CISSA, has quite a bit of information on the public web pages that we publish. So feel free to look at that information. One thing I would also say is when I was in my senior year of software engineering. I found it really helpful to go to industry industry conferences and talk to people that were actually working in the industry. So I found that really useful. And also, my university required me to belong to two professional organizations as a requirement for graduation, and IEEE happened to be one of them. So shameless plug for IEEE.
Thank you guys so much. That's a huge, huge help to me.
I will follow up on Mike's CTF, capture the flag idea. Virginia Cyber Range hosts a number of courses for Virginia instructors, but also nationwide. And they organize CTF competitions regularly. And they range from some basic ones that are compiled off of tricky questions to more technical ones. I know that they're offering currently this semester something around 400 courses. So there might be a way to get enrolled in one of those and join some of the CTF events in the future. Thank you.
Alan, did we have any more questions?
We don't have anything in the chat. I'll throw out a question. I'm trying to figure out in my head, because like Mike, my background is in the embedded world, and I looked at my router just now, and there's 28 IP addresses being pulled, and only 3 of them are traditional computers. So all of the rest are IoT devices or something along that line. And my experience has been that in many cases, when somebody puts an IoT device out there, they don't think about the fact that someday it's going to have to be updated. How do we change that, that throw it out there and forget it kind of mentality? Because some of these devices, you know, are very expensive, like a car, you know, that now has downloadable software, and you can't just throw the car away because it's got this terrible vulnerability that could make you go off into the ditch someplace. How do we change that mindset of the developers that think you don't have to support it after you release it?
Yeah, well, I'll this one. Back in December of last year, there was a law passed, and it's escaped me what the name of the law is, but it requires that IoT devices sold to the federal government are going to have to satisfy some new standards that the NIST is going to have to develop, and I guess are in the process of developing. So, and one of those will almost certainly be some way of automating the update of those devices. And I think it's absolutely clear. I mean, you know, I know that for the product we had several times the need to update our software, not because we were changing anything, not because we were we had any new bugs that we had to address. It was because some library that we relied upon had a critical vulnerability, and we needed to push that update out yesterday, you know, as soon as possible. And even in cases where we didn't think or we didn't know of any way where that vulnerability could have been exercised in our system, we still needed to make sure that that we did test that part of that part of our robustness and get the software out. This is actually a much bigger problem. Is just the whole issue of unknown assets in a corporate network. many corporate networks now have the problem that there are lots of devices. Some of them are BYOD type devices, that are, that employees have brought in because it helps make their workday easier. Now that people are working from home, and are using VPNs to connect into to their corporate network, which is supposedly all secure, and now their computer is supposedly secure because it's in the same IP range. Well, it's also able to talk to that printer over there, which may have been compromised. And so these are all things that need to be addressed, and there will be it'll get worse before it gets better, most likely.
I think you're right. That there's been some high-profile hacking events. The casino that got hacked into through the aquarium is one that comes to mind offhand. Nobody thought about somebody tying in through the aquarium to get to the casino's IT system. So.
Yeah, why do you need a network-connected aquarium thermometer anyway?
I guess it's a cool use of a Raspberry Pi, huh?
Yeah.
It's the convenience that's killing us. Things are convenient, and we sometimes pay high price for that.
So I think we're getting close to the time, right, Alan?
Pretty close, yep.
So maybe we ought to give each panelist 2 minutes just to anything they want to highlight. This is your platform. Go ahead. We can start with Mike.
Okay. So one topic that we really didn't cover too much, and as this is an audience, I believe, largely of students, the message I kind of want to convey is that the most complex systems are not the product of a sole developer. Dozens or hundreds of folks are likely involved in all the myriad of decisions that are made. And there needs to be a common sense of ownership so that everyone feels empowered to make the software better. Well-built software tends to be simple. As you learn more about the problem you're trying to solve, it'll likely reach a point where you need to refactor the system to design in new features. Well, you don't want to break things when that happens, so you need to have systems in place to make sure that when such a refactoring is necessary, it really you can ensure that you have the tests in place to make sure that you haven't broken something critical. This is a common understanding of how the system is built, makes it easier for everyone to participate in this process. This is the basis of good software, and it doesn't have some untested corner cases that could result in a vulnerability at some time in the future. So this is the sort of thing that this is kind of a software hygiene thing that oftentimes doesn't get called out as being a need in cybersecurity, but in my view, that is something that we need to address. All the other things that we got are all valid points, and I'm not saying this is more important or less important. I just think it's something that we probably need to consider along with it.
Thank you so much, Mike. Steve, closing thoughts?
I would echo this similar to Mike. Everybody's part of a team. No one person makes a whole piece of software or a whole application. It's all made up of different pieces. You may work with one service of it, but it's really commenting the code so somebody else is able to understand what you've done, be able to maintain that code, because likely as you progress through your career, you may not be the one maintaining that code in the future, and it's up to somebody else to figure out what did you write, why did you write it that way, and what does this thing actually do. So like naming methods that are actually meaningful, variables that are meaningful, and as Mike said, keeping it simple. Don't go overly complex, because the more complex, you're going to have pages of comments to try to explain what we did, when maybe it was you could pull a library that did it for you, or a couple of lines of code that they're more may not be as elegant as something very complex, but it gets the job done and it does what it needs to do.
Thank you, Steve. And Dr. Manning.
Well, I have a solution for all students. Enroll in VCU. We are NSA certified in cyber defense and research. We have concentration in data science, cybersecurity, and software engineering. Now, what Mike was saying, I have a typical last slide whenever I give a talk, and it has a quote from Leonardo da Vinci. It says, "Simplicity is the ultimate sophistication." So that's a serious quote. And then I also have a caricature of 3 birds sitting on a wire, and 2 are sitting very calmly and chatting to each other, but the other one is just hanging on a wire and really nervous that it'll fall down. And the other guy says, you're overthinking it, Phil. So don't overthink it. Keep it simple, and you'll save yourself a lot of headaches.
Thank you so much. Alan, did you have some closing comments about the Computer Society?
Okay, here, let me share my screen again. The link to the recording of this meeting, I'll be posting it back to the registration page. So you'll be able to go to the same place that you went to get the original link to this meeting. So that'll probably be posted a little bit later on tonight. If you're interested in joining IEEE and IEEE Computer Society, you can go to IEEE.org/join. And just today, Computer Society sent me a discount code that they said I could pass on to others. So CS21R3 will give you a 20% discount on Computer Society membership or affiliate membership. And if you want a free subscription to the Computer Society's Computing Edge magazine, you can go to this URL here. Let me paste this one into the chat because the other one is easy enough to remember, and this one is the same as what you did to get in to begin with, but this one is a bit long. Okay, so I pasted that into the chat. This is a free magazine that IEEE has. IEEE's Computer Society publishes a lot of different magazines, and they select certain articles from 12 of the different magazines that they publish, and every month they put them in this free one over here that you can access. And that's about all that I've got.
Well, thank you so much, all the panel members, Alan, and all the people that attended tonight's webinar. And I'm really, really happy that this went off so well. I think it went off really well. And that's all we have.
Okay, thank you, everyone.
Thank you.
Thank you. Have a good evening.